Yeah, thank you for the introduction. I'm not Jack Elston, I'm Maceij Stachura, but just filling in for Jack. I'm the CTO of BlackSwift Technologies. Otherwise, our bios are quite similar. So today I'm going to be talking about, from BlackSwift's perspective, small UAS for ag. Kind of divided the presentation into two parts, where kind of first half lay the foundation for kind of the UAS industry, what BlackSwift does, and then the second half focus on some ag applications we've been working on. So first off, sort of the big picture level discussion. You know, the reason we use small UAS or any of those things in general is the data they can provide us. More importantly, the data they can provide us on demand, where we need it, at local size scales. And then the point is that that data will eventually be converted or utilized as actionable information to, improve quality of life, those kind of nice things, and specific to ag, looking at kind of decreasing costs, decreasing workloads, and increasing yields. On to the next one. So just a bit of background of BlackSwift Technologies. Our founding team, which includes myself, Jack, and Corey Dixon, have been working quite a bit in almost every area of unmanned aircraft. Over 10 major scientific deployments. I've actually myself have written over 150 FAA approvals. We have over 2,500 legal flight hours, and all from the University of Colorado. You can see there we've worked from everything to, we've done Arctic operations, we've done severe storm research in Nebraska, Kansas, and eastern Colorado. We've developed new systems, integrated new systems, sensors, multi-aircraft, kind of run the gamut of the entire industry. And a bit more of a background on just UAS or drones in general, looking at is kind of where the industry started was more on the DoD side. And the DoD sort of concept of operations was advanced operators, they're essentially pilots. They understand airspace, talking ATC, aerodynamics, everything you need to understand to fly an aircraft. And that's sort of where the industry got started and where the technology sort of originated. More important to this discussion is how we've managed to sort of take similar concepts but apply them to much lower cost, much simpler to use, much smaller systems. And really what enabled that to happen is consumer electronics. So this is kind of just a simple illustration where, we take technology from cell phones, mainly GPS units, radios, and inertial measurement units, combine it with, pressure altimeters from, say, smartwatches. And that kind of gives you, your quadcopters, your aerial platforms. And then the only piece we were missing sort of were airspeed sensors for these fixed wing, larger aircraft where the BlackSwift focuses on. And kind of funny for that one, that came from pressure sensors that are in washing machines. So as you can see there, the consumer electronics industry really kind of lowered the cost and made these sensing technologies available to enable us to do really interesting kind of new applications in this space. Sort of the other reason why we care and what's sort of enabling the industry is, in quotes, big data. Specifically, with BlackSwift systems, sort of our biggest data collecting platform, our soil moisture system, actually collects up to a terabyte of flight. So you can imagine crunching through a terabyte of data. In the past was nearly impossible. Now it's something readily available. We have internet connections or servers and computers powerful enough to crunch through that, down to a more typical mission. You're still looking at 3 to 5 gigabytes of data that you're still having to crunch through, stitch together to get useful information of that raw data. So that industry and that new area was sort of a big enabler of why we see value in these small unmanned aircraft. Sort of continuing forward now, in the flight heritage piece, there's been an absolute explosion in the hobby market. Maybe a better way to call it is actually the consumer market. This is your low cost drones, the small ones that you can buy on Amazon. You can be flying them the day they arrive, simple to use. It's not the focus of our company, and sort of in our opinion, shouldn't be the focus of sort of the ag world, where that's more of the industrial application. You need something that works well, that is reliable, that is fixable, and more importantly, not a knock against these quadcopters or smaller systems. They just don't have the coverage for real commercial farms, bigger areas, that kind of thing. And that's where we see the kind of the value that we provide in companies similar to ours as well. And just to kind of put it on a simple little plot there, kind of a cost versus capability. The hobby industry is extremely low cost, but the capabilities it needs, and specifically for these industrial applications like ag, like surveying, not quite where it needs to be. Versus the DoD side is just greatly exceeds the capabilities you need, but at an extremely high cost. So we're BlackSwift kind of sits between those two extremes, I would say. And then sort of this next slide, sort of an overview of what we deliver, kind of the philosophy and the why. So really what we're looking at doing is kind of taking what these small aircraft are capable of doing, kind of what they can do to provide help to people, and how do you bridge that to get the people the data that the users need. And we do that by, we develop sort of everything in between that chain, the software, the hardware, the integration piece, the algorithms that enables simple operations, yet giving you very powerful data, powerful results. Sort of our key piece that makes that happen is our Swift Core flight management system. That's just a combination of our autopilot, ground station, tablet software that we run, that runs as sort of the base for everything, including the ag systems that I'll be discussing a little bit later here. And there's kind of one more slide there on what the Swift Pilot is. And the architecture we've developed is very modular, a lot of plug and play modules. We can add new sensors, they become online. We find that as a key capability because as the technology improves and as people find value and bluntly ways to make money in these industries, the sensors will get plentiful, cheaper, and better. And we've sort of tried to position ourselves and our technology to be able to integrate these new things, integrate these new technologies rapidly. And then just give a quick background on some of the other areas we're developing besides ag. We've been very heavily involved in doing atmospheric research, as I alluded to earlier. Looking at developing, this was specifically a NASA project where we're developing multiple aircraft systems with, so you can keep using small aircraft with different sensing payloads to do different kinds of atmospheric profiling. This specifically project that's ongoing throughout this summer is looking at using those to map the plumes of volcanoes with various sensing technologies. So sort of as a just high-level picture, kind of summary of what BlackSwift does, we span the gamut from just simple cameras in the sky, taking photos or videos, more advanced sensing technologies, looking at emerging technologies, and then bleeding edge, I lump in there some of the work we do with NASA and NOAA. We also have a lot of expertise dealing with the regulatory environment, specifically the FAA, and then more importantly for us, NASA, who has a kind of their own regulatory requirements. All right, so that was sort of at least my view of the background of the industry and sort of where BlackSwift stands within it. Now the rest of my talk, I'm going to focus on kind of how we use that foundation in the ag world. And from our perspective, we are not ag professionals, we are UAS professionals. So to be able to work with or add value to the ag community, we're looking at doing a lot of different strategic partnerships and working with a lot of different groups. The main ones we work with are University of Nebraska, OSU, and CSU, along with we do some work that relates to a little bit of ag with CU, but I would say the other three are sort of the big ones, and those universities and those schools are a lot more focused on the agricultural world. Sort of the three primary areas I'm going to discuss the technologies we're developing that have value for agriculture are, first off, just the simplest aerial maps, then looking at some of the more advanced multispectral and thermal sensing, and sort of the last one, which will be the bulk of the last part of this presentation, will be soil moisture mapping, which is sort of the main technology we've been developing that we think has value for the ag world. So just quick, got a couple pictures here. Obviously, anything, any area or industry where you're dealing with large areas of interest, visual inspection has value. So there on the top right is actually a photo we took of a farm in Oklahoma just last week, actually 4 days ago. And that's part of, I just grabbed one image of it, but we're doing a full survey. The farm is a quarter section, just doing a full 3D survey of the area. I don't have the image for that yet, it's still processing, but on the bottom left there I put sort of the end result of that. And for ag, like anything else, having a survey grade 3D map of the area has a lot of important uses, from things like figuring out drainage, construction work. We recently, in the last month, overflew a farm to give them a 3D survey in order for them to build a new road on it. And on the other hand, too, aerial inspection has a lot of value for tracking livestock, for ranchers. Storm damage assessments are a really important one, especially this time of year. And the last one is crop monitoring. There's a lot of data and a lot of value just from looking at or getting just visual images, pictures of an area, especially for larger farms. Sort of the next one is this more advanced sensing I mentioned, and this is more of interest to the agronomists. For us, from BlackSwift's perspective, we just integrate the sensors we're told and try to make it in kind of a workable, easy to use way that that can work with. So this is really where the partnerships are important to us. There you can see this specific, the photos here we have is work we've been doing with the University of Nebraska, where we just kind of integrated the sensors and the avionics into one of their aircraft, and kind of, and they're leading obviously that effort to get useful data at, more advanced data, I'd say. And this is sort of, and what I like with this approach, with the research approach, is that there's right now a lot of drone companies, UAV companies that are selling ready in their minds, ready to go systems that give you NDVI maps and things like that. But there's still open research questions as to we can give you a ton of this data, but in the end, where's the value of it? What does it do? Specifically focused on increasing productivity, increasing yield, that kind of thing. And that's where we're excited to be working with these different universities, because they're looking to answer those questions. So before you can convince a farmer or a commercial ag operation to use these technologies, you have to give them sort of a bottom line, and that's, in my opinion, that's still an open question, and that's why we're excited to be at least partially involved with the research aspect in this area. And sort of the last one that I'll focus on in most detail is the soil moisture mapping system. So I'm actually the PI of this project. It's been a 3-year effort where BlackSwift partnered with the Center for Environmental Technology at the University of Colorado and NASA to develop an unmanned aircraft system, a small one that can map soil moisture. The sensing technology for this one is an L-band radiometer. So it's, if you're familiar with it, it's and the reason NASA's funding this is they recently last year launched a soil moisture mapping satellite that utilizes an L-band radiometer to give global coverage of soil moisture, but at quite large scales. Their pixels are around 40 by 40 kilometers. What we're looking at doing with this technology is really providing soil moisture at a much smaller scale. NASA's interest in this lies specifically with helping calibrate their satellites and giving them high resolution data in areas of interest, say with a lot of small bodies of water, to see how well the satellite works. So that's where we're at the research phase now, but we're really looking at finding partnerships and applications where this could be valuable for agriculture. And a lot of discussions we've had, seems like there is a lot of interest and a lot of value in ag. So, so just a sort of a high-level overview of the algorithms. The system is an L-band radiometer, so it maps how much is absorbed and reflected in the L-band at resolutions of around 15 meters. That's 15 meters. It combines this with some thermal measurements of the ground, NDVI, and and then if any soil information we can add to it. We use that at all as part of the algorithm to then give us a soil moisture map at those scales. This next slide here shows, so we did our first light of the instrument, our first campaign in August of 2015 in Canton, Oklahoma. The reason we flew in Canton was because NASA actually has a soil moisture test site there where they have a group of in situ sensors located, buried in the ground. It's part of a larger, actually global network for soil moisture monitoring that's specifically used to help calibrate their satellite assets. So this allowed us to use existing infrastructure from them to fly our vehicle and calibrate it. There you can see some of the initial maps we got on the sort of the middle top and top right images. Now those maps, the units on those are actually, that's the brightness temperature in the L band. That is directly converted to soil moisture. I don't have the map in here, but we have generated those, and they match quite well with the in situ sensors that were in the ground there. So we're quite excited about that. We flew 3 different missions there. We had good repeatability. So going forward, we're kind of doing the next steps to take this from a scientific prototype platform to a commercial platform. So sort of looking at some of the applications of this soil moisture, obviously scientific research, the first one I mentioned, I've gone over. The next one, we're looking at working with other groups to do the soil integrity piece where we combine soil moisture with some knowledge of the soil type and the terrain, and that would enable us to look at soil integrity, look at, kind of go, no-go zones for trucks, military vehicles, that kind of thing. There's strong applications for flash flood and landslides. Flash flood specifically, if you can look at where the soil is saturated, where your storm tracks are coming, you'll know where your runoff is, and you'll combine that with terrain maps, you can help better predict more accurately flash floods. And then obviously the soil integrity piece is valuable for landslide prediction. A little bit of applications for wildfires, knowing how much fuel's on the ground, knowing the moisture content of the soil is actually helpful. And obviously the big one I've talked about so far is ag. So that's it for me. Thank you. You can see the contact information and especially the 3 sites there for more information on our various technologies and what we do. And I'll hand it over to Dr. Wayne Wolt.
Thank you, Maceij.